Sketch the derivative of the given graph. So we have some graph here, and we need to find out what its derivative. Now remember what derivative means. It's the slope of the curve at any given point. So what we're going to do first is to identify some of the key points. What are those key points? When the curve has a horizontal tangent, where is that going to be? You can think of this sliding around, and we're going to end up doing this, and we'll estimate the slope at a bunch of different points. And as it's sliding around, what are the key ones? Where is that going horizontal? Looks like it's going horizontal about here, somewhere in this vicinity. So we're going to have a 0 there. And then it's starting to increase there. It's going to get bigger and bigger and bigger and bigger. And now it's getting smaller, but there's still positive slopes. And it goes horizontal again at that spot. Now what happens to those tan lines? Those slopes are negative, and it's getting steeper and steeper and steeper till somewhere in this vicinity. Then it's going to get, it's still negative, but it's not as big of a negative. It's flatter, and it's going horizontal. So we have another horizontal tangent about here, and the rest of this time is going to start getting more positive. So we can come up with an approximation of these values by just putting our ruler down here and estimating what is this. We're looking at something like over 1 and up 1, 2, 3, 4, 5, 6, 7, 8. So this thing is going to be way up here at 8. And I don't have my paper scale big enough to show that. And then what happens? It's getting smaller. We could just pick a spot in between. Let's say right here. We want to make it so we can see, kind of looking for where it hits integer values, the lattice values. We can kind of see, let's see. I want to try to make it a little bit easier. Maybe I can go and try to hit a point over here. How about this one? So hitting there, it's going to hit and approximately close to that one. So we're going to have over 1, 2, 3, and then up 1, 2, 3, 4, 5, 6. So we have a slope of 2 at this x value, where this is the tangent line, so it's going to be a slope of 2. So we're going to plot a point there. So what we're going to do now is connect that value of 8, which would probably be something in that vicinity, and we're going to connect these points here. And it coming in horizontal, so it's going to 0. Now what happens after that horizontal value? There, the slopes are positive. So where's that derivative graph going to be? If the slope values are positive, those are the y values of my derivative graph, so they're going to be above the x-axis. So they're getting a little more positive as we're going through, and it seems to be the steepest somewhere about there. And now it's starting to get flatter until it goes horizontal again. So we can look about what is this value. That seems to connect pretty close to this one. So that's going over 6, and it goes up 6, 7, 8. So 8 over 6 would be 4/3. And that was around there. So 4 1/3 about this vicinity. So here's where I had my tangent line. And with that x value, I am plotting 4 1/3. See if that would help. And that was my tallest, my highest, my steepest slope. So what's going to happen there, it's going to come up to there, and then it's going to have to come back down. And that was the highest value, the steepest slope, so it can't go any higher than that. And now what happens when it gets to this horizontal tangent? Now it's starting to turn negative. More and more and more negative. And it's going to be hitting, where is it? Seemed somewhere in this vicinity. It's getting that steepest, and then it's getting flatter. So let's see, we can approximate what that is. It goes from about that point to this one, and that would be 4, 5, and we have a, this would be 4, 5, so 9 over 5, about negative 1.8. So at that steepness, we're going to be going down to negative 1.8, which would be in right around, let's see, make sure I have that x value correct. That vicinity looks almost horizontal, so it's going to be coming pretty flat in that area. And then it starts less steep until it gets back to that horizontal tangent line again. And from there it's going to start getting steeper again. And what would be an estimate for this one? It looks like a decent one there. And that looks like up to over 2, so that looks like a slope of 1. So we're going to somewhere around here. And for now, this would be sufficient on how to sketch that derivative. So this graph here would be f prime of x, or dx of f. And then this graph is our f of x. And that's our intro to sketching a derivative.